Hello, guys. My name is João Gabriel Rocha. I'm from the SEQ Unicamp, which is the Chemical Engineering Week from Unicamp. And in this lecture, we're going to present the Industry 4.0 and innovation from a Brazilian lab bench to an international spin-off in the context of the tissue engineering. And we have here Alana Baines, which is an expert in this subject. So you may make your questions in the end of the lecture after Alana presents everything she wants. And so we can start now. Alana, can you introduce yourself?
Thank you, João. So I will do a small introduction. So maybe I will start sharing my screen so we can have the presentation as a guide. Could you confirm that you can see, João, for me, please?
Yes, it's okay.
Okay. Thank you. So first of all, I would like to thank you and your team again for the invitation. It's an honor for me. I'm a huge fan of Unicamp, and I have a lot of connections with the universities as well. So thank you again. So the idea of this lecture is to talk a little bit in depth about the Industry 4.0, having a context on moving a technology from a Brazilian lab bench to an international spin-off. So the idea here, as João told, is to start talking about tissue engineering in the context of one of my old companies. And in the end of the lecture, I will bring another example because I think it's a great one to give a context on Industry 4.0. It's also correlated, and we can bring the topics for both. So as a quick presentation, my name is Alana. I was born in Minas Gerais, born and raised. I had the opportunity to study in CEFET-MG. My main degree is in materials engineering. So I work nowadays as a materials engineer. I had the opportunity to move to the US. So now I'm living in the US in the city of Largo. And the reason I'm living here, I'm going to present for you guys the results that we had in the past companies. So I had the opportunity also to have a sandwich graduation at the University of Birmingham in the United Kingdom, more specifically in England. My current career focus is in innovative materials R&D. So my two huge fields of study are biomaterials and cementitious materials. I'm currently focused on cementitious, but I had a history with biomaterials for the past 4 years. So this is why I'm bringing this as a main topic. So 4 years ago, I was one of the founders of Biomimetic Solutions, which was known as a pioneer company and the only company in Latin America at the time working with cell-based meat, which is a very interesting technology from a food tech perspective. And now I am one of the founders and R&D director for OmniWix, an American company located here in the US, working with a new generation of technology to produce houses. So basically we are printing houses, printing walls and structural elements. So I had a chance to be on Forbes Under 30 by 2019, also thanks to Biomimetic Solutions because the technology got a huge international projection. And now I got the opportunity to got the EB1 visa, which is the green card. So we can talk a little bit more about these opportunities that you guys have in hands also regarding immigration or any other question you wanna do. So let's start with Biomimetic Solutions, and we're going to give context to the topics along the presentation. So Biomimetic Solutions was a biomaterials company that turned to be a cell-based meat company that was born inside the Brazilian university. So Biomimetic is categorized as an spin-off, a technology that went from a research, from a doctorate, it was actually a doctoral research from one of our researchers and professors that became a product in the market. So it was a very interesting. So this is the lab where everything started. This is the biomaterials lab in Cefet. So this company was based, it was a spin-off because it was a very interesting configuration. We were, our board members were made by 2 professors and 3 students. So at the time I was a student from those professors as well. So I was holding the position of the CEO. So I was more focused on the business side. Here on my side, you can see Aline. Aline was the first one to develop this technology during her PhD. So she started working on nanofiber technology. I'm going to explain a little bit further, but this was actually what turned to be our product. Roberta was a specialist also in nanotechnology, which contributed a lot to our product. She's a PhD and a professor of biomaterials in Cefet as well. And we had Lorena and Ana. We were both students at the time. Lorena was helping me at the sales and the business part, and Ana is now a specialist in cell biology. So she's following career over there. So our team was very diverse. So we had someone focused on business, two professors, two PhD holding our research, and Anna, which is specialized, turned to be a specialist in cell biology. So this is actually the product we're talking about. So here you can see what is a nanofiber. So a nanofiber is it's like what we call a scaffold. Scaffold is a structure. You can see a thin layer. Look into this picture. It's a thin layer, but actually, when you look into a microscope, it turns to be a 3D structure, as you can see here. So this 3D structure is considered like a support for living cells. Scaffolds are being very like a hot topic on biomaterials because they have huge possibilities. They can turn to be, for example, skin replacements. Because if you use a scaffold as a skin protector, you can give incentive to skin cells to cure burns, for example, so injured tissues, and at the time we didn't know, but you can also use scaffolds for cell-based meat cultivation. So you can see in this picture how it turns to be. So the cells can see at the microscopical level as this picture right here. So they have an adhesion to the fibers. Those materials, in case they are edible, they are safe, they're food safe. We can process this material inside our body without having any toxin free in our body. And this is actually one of our microscope pictures. So you can see the cells. This is a C2C12, which is a myoblast fiber. It's one of the stem cells, like one of the cell lines that we were using to validate the product. So how this product turned to be an actual technology to the market. So when biomimetics started, we didn't know actually that cell-based meat market was a possibility. The only thing we knew is that the five of us, we wanted to take a technology from a patent that was founded inside the university and take to the market. Because we had this issue, this dream of having any technology being used in a commercial way. So having a meeting with the team, we understood that Aline's work, that was the base of what we explored, was a good product to be used, especially for skin damage. At the time, we didn't know about cell-based meat market. So as you guys know, everyone in the university, we don't have a proper business base. We don't have a proper business solid line. So we didn't know anything about financial. We didn't know anything about administration. So we enrolled in pre-acceleration programs, and they did all the different for us. So people from academic world, I just wanted to share that pre-acceleration and acceleration programs can be because we have to pay attention on the equity, on what they are asking back, but can be a great support to start transitioning from the academic, for the pure academic world, to also having a context on the negotiation business. So we enrolled on Bio Startup Lab, Fieng Lab, and Rebel Bio. Those two are Brazilians. Rebel Bio is an international one that did our internationalization process. And what we gain making part of it. So pre-acceleration programs, they can help you to transform your research into a business model. They helped us to change a little bit our researcher mindset, because when it's kind of like the hot topic today to talk about mindset, right? But when we talk about mindset, we want to say about developing this self-esteem, this capability to be enough to have enough confidence in your technology, how to present this to investors. Financial world is a completely different from what we came from. So those type of programs, they can give us a little bit an understanding on how do I raise money, how do I deal with millions, how do I deal with equity in my company, and change our mindset from just like the academic world to this business one. They also helped us with market entry strategies, FTO, which is freedom to operate, which means if I have a product, can I sell it? Is there anybody else selling the same product? Is this product already patented in another place? So they help us well with FTO. So we make sure that we are not burning any lines of the intellectual property. Product validation. So those pre-acceleration programs are really good in terms of giving you introduction to connections. Unfortunately or fortunately, academic world is something very lonely. We know that our research, sometimes we live in our own world. And when you go to the market, the thing that you need to exercise every day is connections, meetings. So they can help us to develop this soft skill of going to product validation and market entry. So when Biomimetic started, we were validating our product with those two pre-accelerator programs for as a wound healing. Wound healing is bandage, like bandage. I'm mixing with Portuguese because this specific term is not that like very common. So you can use to cure burnt skin. So our idea is was to validate the nanofiber as a support for skin cells, for myoblasts and fibroblasts, and to see if we could support to repair damaged skin. However, we started validating this product here, and we couldn't find much market. We talked with Natura and some big companies. Natura actually doesn't test their products in animals, so they actually grow an artificial skin. So they grow this artificial skin for testing every product. So if we thought, okay, they might be a great client, but in the end, they produce their own skin. They have a really small demand. So we started to look to the international market, and we found out that was a program happening, a competition happening here that is named, I just forgot, Startup Games. Sorry. So Startup Games was an international startup competition that happens all around the world. And bring connections from governments from the UK government. You can have connection with the foreign governments. So we went to this specific competition, and we had the honor to be the first place among the 73 companies that were there. So it was a negotiation competition. So we started selling what Biomimetic was about. We told them, hey, we're 5 researchers. We really want to take this product to the market. And we want to explore the international market. We want to bring this product to different applications that just not wound healing. So we had the opportunity to get the first place, and then UK government members were present on this event. This is why it's also super important to be part of network and connections, because we met government members from England, from UK there. And those guys told us, hey, your company is part of our strategic investing line. So we want to invest on your company. We want to bring your company to the UK. So those was some of the headlines that were at the time. This was by 2017, 2018. So long ago that I'm already starting forgetting the deadlines. But it was, if I'm not wrong, it was in 2017. So from this specific event, we had the opportunity to go to an internationalization process. So UK government presented us to some global funds. Among them, one of them was named SOSV Partners. And this fund made an investment on our company of $100,000 at the time, which is more money than we ever saw for our own research. So here you can already see one benefit of moving to this ecosystem, the money. So in the academic routine, we are used to get money through grants, government grants. And we know how much effort takes to make a government grant to be released. So here we were able to get $100,000 for the research in a in a more easy way. Of course, we had to give equity back, but this is a great deal also for researchers to start the internationalization process or even to boost your research. So this beautiful building right here is Imperial College London, where our new house. So this is where our company was established. In the end, UK government asked us that the matrix, the main base of the company, should be in the London. So in the end, our company turned to be a UK company, not a Brazilian company anymore, which is an interesting topic as well about innovation ecosystem. So whenever we got to London and to this new phase of our development, we developed a whole new business strategy. Our business strategy started to be more focused, more market focused, and not just the applications that we thought it might work. So we start to have a more market demand, a more deep market demand focused research on tissue engineering in regenerative medicine. We also developed a small process. So whenever we went to get a product ready, we would start with research and demand. Then based on the demand, R&D team, Roberta and Anna and Aline would develop the product, validate, keep on the cycle until the product is ready for the client. And then we came to the product engineering part. So we started to have a more sharpened processes here. So then was when we discovered cell-based meat market. And that's the most interesting part, because we were stuck with our product without know where to go, where we could fit that product better. And SOSV Partners, as an international fund, they told us, we know a market where your product will be probably really great and essential. And they're like, where? So they told cell-based meat market. Cell-based meat market is basically a revolution that is happening on the way we consume food, more specifically meat. So cell-based meat market has what they call cell-based approach and plant-based approach. The plant-based approach, probably you already heard about Impossible Burger, which is made out of plants and it tastes really close to the normal meat. This market, you are actually reproducing the meat. You are taking animals' stem cells and giving an option to the consumer of not eating the traditional meat. It's not a competition, it's an option. We still, this market still doesn't have enough force. It's not big enough to end how the food is made. You know that the big players, they are big companies, JBS, big companies in the field, investing in traditional animal slaughter. But this is a new way that you can consume it, more sustainable. So we estimate that you can save until 70% water reduction use and land reduction use. Because you need basically a controlled environment. You can do this in a factory. You don't need to have farms and enslave the animals and make the animals suffer. So in addition to the economic gains, because you don't need land, you need less water, you have the sustainability approach what it is also causing a lot of commotion around the world for this type of technology. So here it is. This is a picture of the first company to create cell-based meat. His name is Mark Post. He is, I'm thinking about, I will confirm the country where Mark Post is, but he's from Europe. And he was the first scientist and the first company to create a meat based on cells. It was an interesting process because this guy cultivated cell by cell. The history behind this company on 2012 is that they filled a room with plates, with those petri plates, just cultivating the cells. It was a huge and expensive. The first burger produced using stem cells cost around $100,000 a burger because this was the price they paid to get this done. However, the past years, the next years, the process is getting more mature, is getting a lot of new companies involved, a lot of money being dropped out on this technology. And this is how the actual process works. So what we do is we start with a cell isolation from an alive animal. So this is what we call a live stock. So stock of stem cells. And we don't need to hurt the animals in this step as well. For example, on a chicken, some companies are extracting stem cells from penas. I forgot the word. Fade, from a fade of the chicken. So you don't need to actually hurt the animal as well to extract these stem cells. You don't need to use like the injection here, as you can see. So then the stem cells are extracted, taken to expansion in a bioreactor. This bioreactor will do a small movement containing also medias, growth medias. Those growth medias are based on nutrients. They have nutrients that are necessary for the cells to grow. They have another elements that are necessary to activate the cell growth, some other additions. And then the third step, our idea is to take that to a maturation in a scaffold. So you are taking the cells that are growing. So in the bioreactor phase, we expect proliferation, cell proliferation. So you come from one, it's like a multiplication process. One that becomes two, two that becomes six, and you go like in a logarithm scale. Those cells are bring to a scaffold, which is it's gonna give the shape, so they can grow, they can attach to the material, and then the ideal, of course, this is a very short version of the process. You can have the ideal process will deliver to us a beef with thickness, with a great thickness. So nowadays we have a lot of companies all around the world that are cultivating beef, pork meat, chicken meat, and even duck meat. Because one of the also most expensive meats are tuna and duck meat. So there are companies cultivating stem cells from tuna and stem cells from duck meat for aga. It's like a specific part of that. I think it's the duck liver, which is extracted to produce a food. So here's a little bit more technical, but I just wanted to let you give an understanding, or our benchmark and metrics. So how we were doing our tests. So we were basically having different prototypes. So we had prototypes. Those prototypes were submitted to different tests, the adherence test and differentiation test, which are two critical features for our product to work. So of course we need to have a metric here. I'm not going to enter in details, but we have a metric on what is acceptable for cell adherence, and we have a metric on what is necessary for cell differentiation. And if the process is approved, then you have a proper cultivation on the scaffold. So you can see that we can try, for example, nanofibers in a random alignment way, because here, for example, let me show this. This is a random nanofiber. The alignment is random. You see that all the fibers are like in different directions. You can actually have the fibers like 90 degrees, all aligned. You can change the orientation of the fibers and measure the impact on the cell growth as well. So you can have aligned nanofibers. You can change the materials and validate. Is it alginate, a good material? Is it cellulose acetate, a good material? Rolling over through this specific methodology. And differentiation, as you are from chemical engineering, is an important process because you're basically stem cell is like a basic cell. It can turn to be a muscle cells. A stem cells can turn to be a skin cell. It can turn to be a fat cell. So one stem cell, depending on the stimulus that you give to it, it can differentiate in different groups of cells. So this is why cell differentiation for us is important here as well. Another important thing is over here, FBS free serum. The industry, until a time ago, on this part right here, on expansion in a bioreactor, some companies were using CBF media, which is fetal bovine serum. They basically really extract the serum from like babies, the small babies, dead babies from the cows. So which is also not very animal friendly. It's a very suffering process. So we were proposing FBS free serum. Okay, so this is an overview on the product. So how we were managing the intellectual property. This is an important topic also for every researcher looking to enter the market. How do I protect my technology? How do I protect my creation and negotiate with the university? Everything. So biomimetic, we have made the deposit of a couple of patents. So this first one was our main product, which was a scaffold containing anato. Basically, we were using urucum, which is a very specific substance here. Urucum is known by not necessarily for this product, but it's known in our culture for regenerative properties. So urucum has really great regenerative properties. So we started understanding and patenting this technology to see if we could improve the regeneration rate, the proliferation rate, right? And we had another patents here that I'm not going to talk about, but we also had a scaffold for cardiovascular tissue engineering, which means a scaffold, it was a foam used for cardiovascular applications. So what we took as an IP strategy here. So basically, one thing that was very interesting for us is to see in a practical way the difference between patenting something and a trade secret. Because in general lines, most of you probably know that a patent has some clear advantage. For example, you have your IP protected for 20 years. You can have your IP protected along 20 years, and this is a strong safeguard. It's considered a strong strategy because you're basically giving a monopoly on your invention, right? But in academic world, professors know well these people are looking to those patents. Competitors are looking to your patents. They are reading your patents because the patent is public. And they have the chance to read your patent and change the process behind. Change a small part of the process and try to repatent a new product over yours. So a patent is good, it's clear the advantage, but we also need to consider your product maybe not publish everything. You can publish just a small part of your process. You need to make sure that you make difficult to the competitors' lives to understand your technology. You need to protect the technology without give all the details on the patent. Otherwise, people will copy anyway. So this is where trade secret comes as a great strategy as well, because we don't have drafting, filling, maintaining patent costs, which are really high. To deposit a patent here in the US, if I'm not wrong, we are paying around $10,000 just for a patent here. So this is for one country. So if you want to protect in another countries, the price goes up. And a trade secret does not need to be filled or approved because a patent goes for a whole process of like a searching. The patent organs will ensure that you're not patenting everything that already exists. So in our case, what we decided, so we looked to our product, the nanofiber, and we decided that, okay, the nanofiber we would patent, so we patented it. We, of course, we didn't give all the details over there. The crucial details were not included in the patent. Um, Another interesting technique is to patent crucial parts separately. So, for example, a long time ago, I was searching a patent from a company, from a competitor, and I found that they patented like a small adhesion. They patented the adhesion process of the myoblast on a cell. The headline was completely, it was impossible to understand what they wanted with that patent. What they did is, instead of patenting the whole process in one patent, they broke the patent into smaller ones. So when you look at it, it didn't make any sense. They were basically making difficult our life to understand, to connect the pieces. So people, competitors, you don't understand how the patents connect between themselves. So this is another strategy as well. So if you have a strong technology, you can divide the patents, the crucial parts of the patents, and give them a random feeling for whoever is reading this patent outside your company. And we decided to trade secret our production processes. So how we do the processes, how we would make the cells to proliferate, we wouldn't patent. So we would basically have these as our protocols. And in case other companies want, we would need to do like a licensing process, doing like a licensing of our technology, doing like a licensing of this trade processes. So here's just a small summary on what we decide to go for patent and what we decide to go for trade secret. For example, nanofiber alignment thickness production rate, it would be a patent. Nanofiber surface modification, it would be a patent. But the cell culture protocol, it would be a trade secret. Because if I patent my whole protocol, anybody can read, anybody can start reproducing and change a small part of our product, and that's it. And this is very, very important. This is national interesting for us, because if you, as a Unicamp student, you are a PhD student, you develop technology, and another company here in the US or in the UK copies you or change your patent in a way that they can use it, they change small details and they start creating a new patent, you're losing money, you're losing your work, you're losing your intellectual property. Our main coin in the market is intellectual property. This is how you make money in the deep industry, like the deep science industry. Trade secret and patents are your main, what you have to be main worried about. So in case of biomimetic, we were also considering exploring the same product for, as we discussed, as a wound healing. So we were considering licensing some patent claims for the dermal dressing or biotechnology industry. For example, Johnson & Johnson, they have like a Band-Aid, a wound healing that you can apply. So, and of course, we validated this product. This was a research done in UFMG. This research was not done by us, but other departments of biology had interested to test this as a wound healing. So they did like a small cut on the animal. The animal took all the medicines. He was not feeling anything. He just took everything. So we did this to evaluate how does it would actually work in a stock life on dermal dressing. So this is another use that industry could benefit as a wound healing. This is not actually cell-based meat, but here's just a quick pickup on the competitive analysis on what is being making on the market. Of course, nowadays we have another technologies already in the market, but this is just for you to have a context. So first of all, we got validating with a lot of clients. Those were companies all around the world. So we had Meatable, Moza Meat, which is the company from the first guy who founded, which made the first burger using cells. We also talked with Aleph Farms. A lot of huge companies in the market gave us this letter of intention of buying these scaffolds. And in the market, we had a couple of competitors. These competitors' growth, they expanded a little bit, but there's still a lot of room for research and improvement here. So the first one was this Dr. Ziegler. He was researching a starch nanofiber, but we had a couple of reasons on why we wouldn't put a lot expectations over starch nanofibers for cell-based meat culture. So we didn't found any evidence of cellular tests. Starch, starch is amido, so it just is also a very technical word. So the mechanical strength, think about using starch as a fiber, as something that you need to be a little bit more high resistant, mechanical resistant. So if we use the technique of blow spinning, it would melt. So there is a couple of reasons why we presented that the competition at the time was going in a completely different direction that the one we wanted. In a very interesting technology, it was this one, Ecovative. They were also creating scaffolds for cell-based meat, but they were using fungi. They were producing like the fungi was producing like a material, like a foam that was being used as a scaffold. It was really interesting, but we couldn't find a clear focus on the application on the tissue engineering sector. And they were using this material as acoustic applications because they produced a really nice material, like a plate, like a huge plate that they were using for isolation, like sound isolation. And they decided to test it in cell cultivation meat as well. So we did like a huge research on those patent banks. And as you can see, they don't have like a proper application clear for cell-based meat. They didn't have, at least at the time. So what were the challenges that Biomimetic faces? So basically, Biomimetic we ended up dissolving the company by 2020, the very beginning of the pandemic, because we were facing a lot of internal challenges. And you will see now how the academic environment can be crucial. Having in mind some strategies can be crucial to the maintenance of a company if you are planning to found one. Sorry. So first of all, the biggest challenge, interdisciplinarity. So this type of technology, Industry 4.0, works a lot with interdisciplinarity, which means the world is more and more connected. So our technology, in order to have our technology ready, we needed chemistry, physicians, biologists, and materials engineering working together. Because as a materials engineer, I don't have knowledge on, for example, to validate this scaffold inside a human body. I wouldn't know to evaluate the properties that we need to have this as a wound healing. So it's a very tough field because we need a lot of different profiles of professionals working together. So whenever you are founding a company, whenever you are taking a technology to the market, please make sure your technology has a diverse team. Work with interdisciplinarity. This is going to make your life a way easier. Our company, we had 4 materials engineers. So at the point we were, okay, we need a business person. So I decided to go for business side, but we need a biologist. We need a person who can validate other aspects of the product. And it's not easy at all to find these people. So this is why it's important to start planning over it. So another big challenge. I'm not sure if there's any professor watching this, but if there is, they will know what I mean. Full-time professor dedication versus full-time employee demand at the companies. Well, back in 2016, we had a specific normative, like a law that was posted about innovation law. This innovation law is aimed to make sure that professors, for example, can be part of startups. They can have their own startups, even though they have exclusive dedication. However, those professors cannot be the majority partner or the managing partner. This is good and bad. Let's look for the good side because you're giving your professor, okay, because, for example, in our company, one of the big reasons that we dissolved, it's because the investors wanted the professors to stop being professors. So they are like, we need you full time in the company. We need you to leave the university, leave your public job, and join us. Other than that, we're not going to put any money. Because Aline and Roberta at the time, they were the main source of knowledge in the technical part. They had most of the part. Our cell biologist professor, she acts up as a full-time professor in UFMG. So our main academic brains were compromised already with a full-time dedication. And the investors were saying, we want you in the company. Otherwise, we don't put money. And we know that it's easy to do that.
Hello, guys. I think Alana fall, internet fall. So we're gonna just wait a few minutes for her to come. So just wait a bit, please. Oh, hello, Alana. It's okay now.
I'm sorry, we're having a heavy rain here
Uh,
and the internet just dropped. I'm using my personal internet from the phone for you to know.
okay. No, but there is no
So yeah,
problem.
I just need to because I think it seems like Meets just dropped the sharing option. Let me see if it's gonna. Okay, it's coming back.
Okay.
Okay, just a second.
Alana, you can turn off your camera too if it's better
Mhm.
for the sharing. I don't know. It
Let's
improves the
see.
sharing.
You let me know if you can see. Can you see?
Okay, you can continue. Thank you.
All right. Sorry, guys. We just had like a huge outage here in the neighborhood. So it's easy to judge a professor like I would leave the university, but it's not easy because the university, the academic people in Brazil, they are raised to be at the university. Their salaries, the whole structure is stuck in the university. So at the time, Roberta and Aline, they just wouldn't be able to leave also so quickly the university in order to join like a new company that it was still too small, is still too stable. So it's clear for us that we need better ways, better structure career plans for the researchers in order that leave time for them, give time. If you're going to join a company, maybe they should have more time to invest in that company as a professional. not work 8 hours as a professor and more 8 hours as an employee, right? So this was one of these problems that we have that started to turn things difficult for us in order to fundraise, right? Um, and another point here about the innovation law is that one of the points that the difficulties that we were facing was regarding licensing process. Unicamp and USP, those universities, your university is really well structured on that sense, but most Brazilian universities are not. So, for example, when we went to CEFET and we say, hey, we need to do a licensing of this technology, we need to license in this technology to our company in order to start exploring it. They didn't have a process yet. So we didn't have a proper process on how to deal with the equity, how much the university it would take for this. So it took a long time as well. And investors and the market, sometimes they are very impatient with us. The university has a slow pace and they are very like impatient with that pace. Like we want things for now and the university needs a long time. So this is something that we can raise as a topic for improvements in the future. João, is it sound good?
Yes, it's great.
Okay,
it's working
sounds
well.
Good. So let's talk about fundraising process. So how we were working the capital on the company. So this is just a suggestion for if any of you need to start fundraising. So we organized all our process in term around spreadsheets. So we created some spreadsheets. We took around 300 names, 300 funds in the US and the UK, and started reaching out to them in order to raise our next round. In our next round, we were raising 4 million. We got actually half of the round, like investors for the half of the round. But due to the difficulties that we were facing at the time, we decided to stop the fundraising process at that point. By the way, all the other company members, are still working in the field. So Lorena is working in the field, Aline is working. They were hired by huge companies and they are basically leading the process of innovation in cell-based meat for those huge companies at the moment. So at the time we were doing fundraise, the main thing we did is like trying to find investors and venture capital funds. We did meetings and meetings and meetings all day. That's a very, very, very like your emotional side needs to be very sharpened here because it's not easy at all. Like Roberta would have to leave her sometimes her classes in order to go to congresses, in order to go to give to share knowledge within other with investors. So it's a very exhaustive process, but it's worth. I'm giving you the difficult side, but also it's a great way to make money. It can boost your research. And of course, what we want from the investors in the end, show me the money. Put the money in a more fast way because research needs to be, technically, we would need the financial resource a little bit more faster than the pace we have within the government, but it's understandable. So this is like just a contest on biomimetic, and then I would like to bring a little bit on how the internationalization process worked, how the patent prosecution process was done, a little bit of the process, the team. And as I told you, 4 of our founders are now still working in the field. I would be in the field as well if something didn't happen on my way along those past years. So when we closed Biomimetic, I decided to move my studies forward. So I applied for a master in England. I applied for a short-term course here in the US, and I had the opportunity to come here for 15 days to do a short-term course in Ohio. When I came here to the US, and I came here to visit a small part of my family in Florida, they introduced me to a guy, to an entrepreneur named Fernando. This person is amazing. He's a very, very strong background. He by the way, he's not from Unicamp. He's from USP. But he's a electrical engineering that has his degree on USP. He did his career in a huge multinational and lives in the US, but he was kind of bored on working for multinational companies. So he was founding OmniWix LLC at the time. So Fernando was founding this company along with other person. And when I was here, someone from my inner circle told me, Alana, I knew that because biomimetic was selected on Forbes because of the work we were doing. And this person told, I saw you were on Forbes. I have been seeing your work for the past few years. I want to introduce you to somebody. And this person introduced me to Fernando. Um, and and by coincidence, for life things, we never know the explanation behind it. Fernando told me, hey, Alana, I know you just went out of a company, but I'm founding a new company. We are needing a materials engineering to work developing our materials because this company right here works with 3D concrete printing. I've seen that you have been working with like 4.0 industry. You did materials engineering, so you studied in an overall way the different groups of materials. So I would like to invite you to join our company as an R&D lead. So they offered me to join this company with 10% of the equity plus a salary. So this changed the course of my life. This is why I'm here today. This is why I have this green card approved. It was not something that I was expecting, being really honest, but it happened. So this drastically changed my focus. And now my main focus is not anymore tissue engineering, although I've been in contact and studied for a long time on it. But my main focus now is to act as the R&D lead of this company, OmniWix. And I'm going to give a small intro on what we're doing here. So we're located here in Florida. So we have two companies actually. So Fernando, we are partnering with a robotic company here in the US. So we now own the whole process. We are manufacturing the machines and we are manufacturing the mixes that go inside the machine. I'm going to explain a little bit more what this company is about, but we're locating here. It's a beautiful place, by the way. So what is the problem that this specific company is working with? So you can see that automotive, aerospatial, the whole industry section, you can see that we had improvements, right? So for example, automotive sector, you can see that along the time, as the time passes, we are here in the bottom, the waste generated is reducing, the productivity is going up, and the safety of the process is going up. So automotive section passed by a whole automatization process. Aerospatial as well. We know that aerospatial industry has one of the most safe safety process and safety products released every day. But when it comes to construction, it didn't change at all in the past decades. So the waste keeps being generated in a really high amounts. Productivity is not good. If somebody here ever had to build a house or build something, you know that half of your money goes in materials that are wasted on the floor. It's a mess. Like this on-site construction, it gets messed. You lose a lot of raw material. The people working on the industry sector they have one of the lowest safety rates. They do a very insalubre job. It's a very non-safety job for them. They keep carrying weight to in the on-site work. They are exposed to cement and to other raw materials that are very toxic. So home construction sector compared to other sector of the industry didn't change much. And this is where this technology came. So basically what was developed here is that a lot of companies in the US, this is huge also. This is a huge part of the 4.0 industry here in the US. So it's basically a robotic system capable to build walls or any construction element we can reach until 70 to 80% more faster times than traditional construction. The field is still developing. I'm not going to say that we are there yet, but this is why our company came with a different proposal from the current ones. on how to make more efficient this process in order to even beat the traditional industry. So you can see that is a machine. This is a robotic arm capable to turn around 360 degrees. And me as an R&D lead, we are developing together with a really competent team those mixes that go inside the printer. So this is what our business model goes around. So basically, we are a company that is working producing machines. We own now, we own together with 3D Potter, which is like a partner, the right to commercialize those machines and the fabrication of those machines. And we also own the process to build the walls, to build the structural elements using this technology. An interesting thing is that you can do not just walls and houses. You can print a house, but you can print, for example, fireplaces like churrasqueira, any structural element can be printed through this technology. So we are also selling the machines and selling the process to any other company, as well as we are building our first house here. So here in the US, we're building our first house in Port Charlotte, is a city nearby here. So we created 2 patents as well. We already, this one is a provisional patent, so we don't have the proper patent yet. We are still exploring the provisional one, because the provisional patent gives you 1 year. You have 1 year to explore the patent and protect your technology before deciding to deposit your final patent. So it's really interesting technology, and it costs $100, not $10,000. So those are the machines that we are making today. So we are already selling those machines around the world. USP, by the way, USP just bought 1 machine from us. They just bought 1 machine, and because a lot of universities are interested to get this type of machine inside their facilities in order to start doing tests on new mixes, new materials for 3D industry. So we have Potter bots, SCADAs. We also have a printer capable to printing in metal. So literally, the printer can print metal without welding. So it's basically a powder. It's a powder plus a sintering process, like a heating process of the metal. And for example, this is the machine in operation. So this is our mix. We developed the mix, and the machine goes layer by layer, depositing the material and making the walls. So we can actually produce the walls of the house in 4 days, 5 days. That's what we are expecting nowadays. This for you to have an idea on how does it work to build a house with those machines. So you can see 1 machine here, another machine here. So for example, if you are interested to build a house, you can buy 2 machines, and those 2 machines can work at the same time building different walls of the house. So this machine is working building this house. This machine is working building this other wall, sorry. This machine builds this wall. This machine builds this another wall. This is the material. The material is produced on site. So we actually mix the material on site. And we also have this machine right here that goes in rails. So there is a huge rail. The machine can move here to here and print in 360. So with those machines, you see that you have a more safety work as well, because the workers will be monitoring the machine instead of getting heavy things from the floor and getting damage from cement. So it really turns to be a huge improvement for civil engineering field. Here's another angle for you to see, for example. And this is the plan of our first house. This is the house we're building here. This is how it will look like. We still cannot publish anything, any picture, anything, because we want to go further in the project, go far in the project before making like any marketing material. But this is what we're building here in really near where I am right now. So we're printing all those walls right here, and this house is already sold So there is someone who already purchased this house. So this person is going to live over there. We have a lot of regulation going over through this as well. We are passing by a permit process here where the government is analyzing all our documentation. Our material went through all the tests. We did compressive strength tests. We did all the tests according to ISTM, International Standard norms. So everything we are ensuring, and all the other companies are ensuring that the process is safe, although it's a new technology. So government approved. We have just some few items pending approval or between the government, but they are already in process of moving forward with the approval. So this is our first sale. So it's really good, really, really interesting for us. So that's it. I'm not sure how much longer did I talk, but I just wanted to reinforce. It seems cliche. It seems like everyone says that, but we're not genius. Nobody here is a genius. We're just normal people trying to figure out another way to live our lives. It's really good feeling of having a technology out in the market, of having someone using your product. I know the academic research sometimes is not worried about this. Sometimes we need to research things that are not commercial. But if you have this entrepreneurship feeling inside you, it works every difficult. I'm here in the US. I would never expect to have a green card approved. And this was all because of this work, of the people that is helping me, the other brilliant researchers that are also founding their companies. So it really changed my life, all this path. So, and if I was talking to me years ago, I would say this to me, like, because it seems impossible, but something is impossible until you go and you do, and small part by small part, it's everything turns to be a reality. That's it. I wanted to thank you all. I'm sorry for if I passed the time. I'm sorry for the dropping out. But this is my email. Anybody who wants to get in contact for any of the companies, any of the topics, I have the right connections to put you in contact with people from Cell-Based Meat as well as currently working actively in this company. So feel free to take my contact as a reference. Thank you.
Thank you very much, Alana.
I think that's it.
I loved your lecture. It was really good.
Thank you.
I thought it really interesting to me, and I think everybody that is watching thinks the same. So we have a few questions already. So I'll bring it to you.
Thank you.
Okay. Eric asked, what specializations does a chemical engineering student need to be successful in this kind of work?
So is it Eric? Well, let's do the two technologies. So, for example, for tissue engineering, there is something that you can do that we need a lot, like chemical engineering. For example, the bioreactor process. Chemical engineers are used to work with tanks and process every time, right? You guys are own a lot of responsibility on industrial process. So we don't have an effective bioreactor process yet. So the industry doesn't know how to expand in a more efficient way the proliferation cell. So for example, you can do an specialization on industrial process for bioreactors. You can bring your knowledge of like batches. How can we split this into batches? How many batches we can split this to turn more efficient? How can I modify this equipment in a sense of production to make more efficient the cell cultivation process? So if you look for an industrial process, we have a lot of room for chemical engineers. So you can specialize yourself, for example, in industrial process and propose a thesis on just a bioreactor study on how to improve differentiation. You can work also on how to merge scaffolds inside bioreactors, for example. You can work, engineers are also administrators, right? So you can do specializations on, for example, how are we going to improve the sales chain of these products? Like, how are we going to do a factory? How are we going to implement a factory for this kind of product? So there's a lot of room for chemical engineering, definitely. Even more room for chemical engineering in this specific technology than on the civil engineering. But in civil engineering, I also see from a process perspective, we need people to bring optimization in terms of how to improve the machines, on how to improve the logistic of the machines. We are using silos, for example. We use silos for mixing the materials. And this is another word for us, how to make the mix. Imagine like a cement industry. It's like this. How can we move the silos and mix the quantities of the materials in order to have a product ready? This process part is very hard for us. So you can also do an specialization on any of those topics. I think that is
Thank
that
you.
answer.
Yeah, it was great. Thank you very much. Another question is from Isabella. She asked you, what was your biggest motivation to study this area, to start the tissue engineering, and after going to the construction area?
So the tissue engineering, what my biggest inspiration were my professors. So because we were discussing products that we could take to the market, and Aline has a huge and beautiful work that was being worked on tissue engineering. And for me, whenever we got the chance to produce something that could cure people, in the first sense, cure skin, bring this to save people's, to give a better quality of life, save people's life. For me, this was like shining my eyes. And whenever we found the cell-based meat, this was more even interesting, because we are talking about stop slavering animals. We're talking about stop destroying the lands, helping on the climate change. So I know we are small. We are not the biggest. We're not going to change the world alone. But for me, it was a huge inspiration and huge motivation having this type of like animal cause behind it. And the second thing is, this company I am right now, it just happened. I have to be honest, it happens. Sometimes not even me, I know how I got here. But the fact is, I got the challenges like, do you accept the challenge? I am okay. I am a materials engineering. I'm gonna move my life right now to this company, and I'm gonna make it work. Of course, I'm not a PhD on cement. This is why I hired people to be competent people to be by my side, because nobody does anything alone. So I'm learning with them, and now this focus changed really quickly. It was out of my control.
Great, thank you. So one more question. Marina asked, what are the biggest difficulties that you find on your day-to-day work?
For me, as I was working in the business side, was definitely the financial part, because I was terrified when I got to $100,000 in my hands, and I didn't even know how to open a bank account in London. Learning how to manage a cash flow, learning how to build a valuation. I feel enough confident. You as a woman, sometimes we as a woman, we feel the síndrome do impostor. We don't feel confident enough in ourselves to do the job. So sometimes I was feeling like, am I really talking to a bunch of millionaire guys, and they're going to buy my purpose? They're going to find me like a competent professional. So I got stuck in a lot of those meetings, questioning myself. I cried. This is my happy. Those are just the easy part that you guys are seeing. But I cried a lot. I had a lot of moments that I had to, like, hey, come back, focus, and go. You're gonna do it. But yeah, those are my challenge. Going out of my field, because I was not an administrator at all. I didn't know much about finances. I didn't know much about investment. So this was the hugest part, hugest challenge for sure. But we learn. Life teaches us and study, not life just, but study.
Great. I have a question too, actually.
Sure.
When you were talking about the tissue engineering and the production of meat, for example, I know that there are different types of technology, for example, that produces the meat. In in your company you had, how it was like you could extract one cell and reproduce forever, like you didn't have to take other cells from the animals, or you had to do it again like once a month or
Yeah.
a year. How was it?
Yeah, this was like the cells when they start reproducing, they have like a shelf life. So whenever we got the cells shaped in a product, they had a shelf life. We were estimating at the time, we didn't have a precise estimation, but we were estimating at the time around 30 days that we were using the same batch of cells in producing. But after that, the cells start to die as any other like product. They have like a valid like um prazo de validade ali para ser usado. So yeah, so they had a shelf life definitely. So we couldn't use just one cell as a source. But one interesting thing is that nowadays they have what they call cell farms, as stem cell farms. So it's basically fazendas celulares. Em português é muito mais bonito o tema. Stem cell farms. So basically are people creating companies just to cultivate the best cell line for cell-based meat, for example. Cultivating the best pork cells that you can get from the best species, from the most healthy species. This is creating a whole new chain of events around it. Like professions, new professions.
Yeah. I find this area very, very interesting of this sustainable thing about how to eliminate the waste of all this production, like of meat that is really harmful, right, to the animals, to the world, and this is really, really, really great. And the other part that you showed too of the construction is really interesting because it's a lot of waste too. So it was really great. So
we are open to partnerships as well. So if Unicamp in any sense has interest to talk to us to see how we can help as well the university to start moving forward on those 3D construction field, just feel free to get us in touch with any professor that makes sense.
Great. So Alana, we don't have questions anymore. So I think
sounds good.
We are okay now. So I may finish the lecture. Thank you very much for coming. Your lecture was really great. And I hope you all that are watching enjoyed it. And so I ask you to fill the forms, the feedback forms that will be released in the YouTube. So please do it, and you may gain some gifts for doing it. So please do it. And again, thanks, Alana, very much for this.
Thank you all. It was a pleasure. Feel free to find me on social media. I'm gonna is there a way to share social media with people in case they want to get in contact for anything? Well, I can find a way.
Yeah, sorry, what was the...
Is there a way to share social media with people? So if anybody wants to get in contact, they can find me on LinkedIn. If I type a comment here, I don't think they will see it, right?
Yeah, you can send me and I can send to them too. It's okay.
Sounds good. Sounds good. Thank you, João. Thank you. Thank you all for the support.
Yeah.
Enjoy the lectures. Bye-bye.
Bye.